Now we're going to take a look at the fish market data set that we looked at before in R programming, but we're going to try to do the same thing in Python. So in order to get things going, first we have to import the pandas library into Python so that we can work with this data frame. Again, the reason we're importing pandas is because this data frame has numbers as well as other values besides numbers. It has the category of what kinds of fish we're going to be looking at here. So if I run this code, and I'm saying I want to look at this file, save through this file path, and I want to call it fish, it's going to be reading it as a CSV file, and then ideally it should spit out the first its records from the top going down. And there we go. So we have 1, 2, 3, 4, 5, 6 records. And here we can see we have the species, which again is non-numerical. It's actually just listing off all the different species of the fish that we have. We have weight, we have length 1, length 2, length 3, height, and width. Okay, so now we just want to try to clean up the data a little bit and really just try to give us a little bit better idea of what we're working with. So in this case, I did fish.shape. So we have 159 rows or records and 7 columns to work with. Again, we have 7 columns up here, so that checks out. 159 for the rows, which just gives us an idea of how big is the data frame that we're going to be working with. And in this case, we also just want to get a quick idea of some of the summary statistics. So if I do fish.describe, that spits out the number, the average or the mean, standard deviation, the minimum value, the 25, 50, 75%, and also the maximum value for everything in weight, length, height, and width. Species is not included in here because, again, it's not a numeric field, so it's not something that we can do, that we can take statistical measures on. Now, another thing we want to take a look at is, are there any missing values in this data set? So we go fish.isNull, soft brackets, .sum, soft brackets. And over here we can see, based on every single column, there are no missing values for anything in the data frame, so that makes our life a lot easier. We don't have to worry about dropping values, substituting values, or trying to convert anything. Now let's take a look at how many unique fish values are in each species. So we have at least one species of fish mentioned up here. We have a species called bream, but let's see what other ones that we might have in there. So we have bream, which we already saw. We also have roach, whitefish, parkey, perch, pike, and smelt. Now, another question we might have is, okay, well, now that we know what kinds of fish there are, how many of each fish exist in this data frame? So if I do that, I'm going to go, I want to look at the data frame fish, specifically the species field, and I want to look at the number of values and count the values for each of the types of species. So we have 56 perch, we have 35 bream, 20 roach, 17 pike, 14 smelt, 11 parkey, and 6 whitefish. And you'll notice that it automatically just sets it from the greatest number to the lowest number in terms of species in this data frame. Now, if I want to do something where I just wanted to create a subset of this data frame that was only looking at perch, again, I could definitely do that. That's not really something that we're going to jump into for this, but again, all I'd have to do is create a variable name, set it to the name of the data frame itself, and then of that data frame, I'd be looking at the species column where all the values have an equivalent value called perch. And then I would be looking at the last 8 values going up from the bottom that would all fit that criteria. But we really want to look at linear regression in this case, and we want to try and figure out, is there maybe some kind of correlation between some of the independent variables in this data frame and how they all relate to weight, which is hopefully the dependent variable in this case. So before we do anything, we need to import a few things. So we need to import sklearn.linear_model, and we're going to import specifically linear regression so that we can eventually create a tool and just be able to fit everything in there so that we can figure out, is there some kind of relationship between all these independent variables and the dependent variable of weight. And again, sometimes it just takes a while for the libraries to load. sklearn is a very large library just by itself, so that's why we try to specifically say which part we want to import. So we're not trying to pull the entire thing all at once. So before we do anything else, one thing we need to do is we actually need to drop the species field or column from the original data set. And the way we do this is we create fish_num to say that we're just focusing on the fish columns that are strictly numeric. So we're going to go look at the fish column. We're going to drop this specific column, which is called species, and I'm making it so that access equals 1, meaning that I'm specifically looking to drop the entire column of species. And if I do that, what you see is exactly different from what we had up here, where we have species all the way to width, but down here we just have weight, all 3 lengths, height, and width. So we've cleaned the data up to where we have what we want to work with. And now we just have to define the features, which in Python is what we call the independent variables. So in this case, I'm defining features as everything, as all the columns in fish_num, specifically length 1, length 2, length 3, height, and width. And then I want to display the first 4 features, or the first 4 records of that from the top down. So in this case, we have 0, 1, 2, 3, which are the 4 records. Again, fun thing about Python is counting always starts at 0, so you just always have to keep that in mind. And after we've defined the features, we need to define the target, aka what is our dependent variable going to be? What is our y in this case? So as I said before, in this time it's going to be weight. And again, I want to see the first 4 values for head from the beginning going on down. So we have 242, 290, 340, and 363. And once we've done that, we actually need to create the blank linear regression model. So we're going to call it regression as the variable name, and we're going to say regression equals linear regression, soft parentheses. So creating that. And actually I need to update this so it says fit the linear regression with the newly created target and feature values. So we've created this blank tool for linear regression, but we need to throw in the relevant target that we did up here and also all the independent variables that we're working with here in order to try and create some kind of relationship. So I'm going to run this cell, and once I do that, so the cell has run the model, and now we just have to try to pick it apart. And the reason we don't see anything here and there is we need to look at the intercept of the model and also the coefficients of the model respectively. So when we do model.intercept underscore, what we can see is that if everything was set to 0 for the independent values, we would automatically have a fish's weight of negative 499, which again is which is a nonsensical value because a fish cannot have negative weight. A fish could theoretically only weigh 0, but if a fish weighs nothing, then the fish would not exist at all. A fish in the real world has to have some kind of mass or weight behind it for it to exist. So the intercept by itself doesn't necessarily make a lot of sense, but let's take a look at the coefficient values. So all these numbers that spit out down here are relational to what we looked at up here for, again, the length 1, the length 2, the length 3, the height, and the width. So going in that specific order, we would say for every 1 unit increase in length 1, the predicted weight of the fish will increase by 62.35521,443. And again, if you wanted to round that to maybe just 62 or 62.3, whatever rounding style you want to do is completely up to you. For ones like negative 6.52, negative 29.02, you would actually say that for every 1 unit increase in length of 2 or in length of 3, the predicted weight of the fish would decrease by 6.5 or 29.02 units respectively, and again holding all the other IVs in the series constant. So another way to look at that is if we looked at that, we would see, okay, so the first record that we have that we know to be true from what we predict from not our prediction yet, but from the actual record from the data set, is for this particular record of bream, it weighed at 242, its length was 23.2, its length 2 was 25.4, its length 3 was 30.0, its height was 11.52, and its width was 4.02. Now, if we try to predict some of the features, based on everything that we saw in there, we would see that the weight itself would actually be closer to 326.81, which is definitely a bit different than 242. So that would actually make us want to reevaluate this model and think of maybe there's some kind of interaction term there we want to explore. Is there maybe a polynomial we want to explore? But again, just the fact that 242 is so different than 326, it's clearly not the best model that we can use for this, but it gives us at least some kind of starting point for us to go a little bit forward and try to refine what we're looking for going forward.